This is a review to help you prepare for the upcoming test. We'll start with question 1. Suppose a production line operates with the mean filling weight of 16 ounces per container. Since over or under filling can be dangerous, so over or under, guys, means more than 16 or less than 16. A quality control inspector samples 24 items to determine whether the filling weight must be adjusted. The sample revealed a mean, that's X bar, 16.45 ounces, with the sample standard deviation 0.75 ounces. Using a 10% level of significance, can it be concluded that the process is out of control? Out of control means the mean is not 16, it's over or under. So that would be the null hypothesis, mean equals 16 here. The alternative will be mean not equal 16, and that's where our claim. So what we're gonna run here, a t-stats test to find the test statistic and the p-value. So you go to stat, t-stats. You only use z-stats when he gives you population standard deviation, which he didn't. So t-stats, one sample with summary, and sample mean is 16.45. Sample standard deviation is 0.75. How many in the sample? It was 24, I believe. And we're testing against what value, guys? So you put 16 here and make sure to select the alternative sign, which is not equal to 16. And then you hit compute. And here you go. The test statistic is 2.939 and the p-value is 0.0074. Since the p-value is 0.0074, which is less than 10% right here, so you reject the null hypothesis. And if you reject the null hypothesis, you're saying HO is bad, then you're going to support H1, which is the claim. So you say there is enough evidence at the 10% level of significance to support the claim that the process is out of control. A survey done 1 year ago showed that 45% of the population participated in recycling programs. In a recent poll, a sample of 1,250 people showed that 598 participate in recycling programs. Test the hypothesis that the proportion of population who participate in recycling program is more than what it was a year ago. That means more than 45%. So more than should go to the alternative, and always the equal sign will be in the null hypothesis. So this is your null, and the alternative will be P greater than 45%, which is the claim. We're going to use the proportion stats here. So let me show you how to do that. We go to stat, proportion stat, one sample with summary. Number of successes is 598. Number of observation is 1250. We're testing against 0.45. And we make sure to change the alternative to greater than. And you hit compute. And here you go. The test statistic is 2.02. And the p-value is 0.0218. So since the p-value is 0.0218 is less than alpha, we reject the null hypothesis. And if you guys reject the null hypothesis, you must support the alternative. And your conclusion should be there is enough evidence at the 5% level of significance to support the claim that the proportion of the population who participate in recycling program is greater than what it was 1 year ago. Make sure you don't say to support the claim and pause there. You have to write what the claim is, and make sure to include the level of significance when you write the conclusion. Next question. Marla is studying the sodium content of cold cuts. A random sample of 8 slices of smoked beef produces a sample mean of 15.55 gram of salt with a sample standard deviation of 0.50 gram. An independent sample of 6 slices of smoked turkey produces a sample mean of 12.50 grams with a sample standard deviation of 0.75. Test to see if there is a difference in the mean content of sodium in the two brands, smoked beef and turkey. Use a 5% level of significance and assume population variances are not equal. When he say assume population variances are not equal, that means you have to keep pool turned off when you use static range. So the null hypothesis will be mu1 equals mu2. The alternative will be mu1 not equal to mu2 because he says check if there is a difference right here, difference. And that's the claim. We're going to use t-stats with two samples. So let me show you how to do this. We're going to go to stat. So you go to stats, t-stats, and StatCrunch, two sample. For the first sample, you put the mean 15.55, standard deviation 0.50. How many in the sample? 6. For the second one, the sample mean is 1250, sample standard deviation 0.756. And then here, if he says population variances are not equal, keep it off, don't check it. It's set by default to off. Population variances are not equal means off. And then we need the appropriate sign for the alternative, which is not equal to. You don't touch the zero when you compare two means. Leave the zero right here. And then you can just hit compute. If you want to see the p-value in action, you can select this one and compute. And here you go. Let me show you the screen. So the test statistic is 8.626. It's a huge. P-value is so small, less than 0.01. And this is, look, you don't see any p-value on both sides because it's so small. So if we go back, test statistic is 8.2627. P-value is less than 0.001. Then you reject the null hypothesis. P-value is less than alpha. And if you reject HO, you support H1. There is enough evidence at the 0.05 level of significance to support the claim that there is a difference in the mean sodium contents between the two brands. A pilot study in Fairweather County wishes to determine whether mailing reminders to register to vote to all citizens in the county who are eligible will improve voter registration. A random sample of 1450 potential voters was taken. Then this sample was randomly divided into two groups. Group 1 consists of 700 people. Reminders were sent in the mail to each member in the group. The number from this group who registered was 405. Group 2 consists of 700 people. No reminders to register were sent to them. The number of people, potential voters from this group who registered was 335. Let P1 be the proportion of voters who register in Group 1 and P2 the proportion of voters who register in Group 2. Test the claim at the 5% level of significance to see whether the proportion of potential voters who registered was greater in Group 1. So he wants you guys to test if P1 was greater than P2. Okay, so let's see if this was the case. So this is a proportion stats, and you're gonna enter the number of successes in first group with the number of observations, number of success second group with the number of observations. Stat, proportion stats, two samples with summary. Number of successes 405. Smaller number of observations 750, number of successes here 335, number of observations 700, and we need to check if P1 is greater than P2. Hit compute, and here is the test statistic 2.34 if you round to 2 decimal places, and the p-value is 0.0097. Since the p-value is 0.0097, which is less than alpha, the 5%, we reject the null hypothesis. What is the conclusion that you're going to write here? There is enough evidence at the 5% level of significance to support the claim that the proportion of potential voters who registered was greater in Group 1 than Group 2. Next question that has to do with dependent samples. During a national presidential campaign, Professor Adams asked each of his political science students to do the following project before each upcoming national debate. Select 9 friends to do the following. Before the debate, rate the Republican candidate on a scale from 0 to 10, 0 very negative and 10 very positive. Then after they have watched the debate, rate each candidate on the same scale. Mary did the project using a random sample of 9 of her friends. The results are shown in the accompanying table. Use a 5% significance level to test the claim that the ratings before and after the ratings after the debate are higher than the ratings before debate. So when you work with dependent samples, here's what you have to do. You have to find the difference. These samples are dependent because it's about the friend, what they did before the debate and after the debate, before and after. So you do the difference, 6 minus 8, which is negative 2, 9 minus 7, 2, 1 minus 1, 0, 5 minus 7, negative 2, and so on and so forth. Now, the question is to check if the ratings after the debate were better than before the debate. Ask yourself this question. The first friend had a 6 before the debate and 8 after the debate. That means the rating became better. So so that means under this one it was a yes, it did. This person, just gave better rating. 9, it went down to 7, no. So it didn't give a no, better rating. 1 minus 1, no change. 5 and to 7, yes. 0 to 3, yes. 7 to 8, yes. 3 to 5 is a yes. 8 to 7 is a no. And 5 went down to 3 is a no. Now, what I like you to observe, above the yes, what sign do you see? You see negative, correct? So this is how you decide which hypothesis to test. You need to test that the mean of the difference is less than 0. Why? Because above the yes is a negative sign. So here's what we're going to do in StatCrunch. We're going to put those values in StatCrunch and run a t-stats test. You also can put this one in StatCrunch before the debate, after the debate, and select paired, and then it will do the difference for you. But that's easy to do the difference by hand right here. So here's the data. We put it in StatCrunch. Then we go to Stat. T-stats for dependent sample. One sample because I did the difference already with data. This time we're going to select data. Okay, where is the column? Very good. Right here. Okay, and right here, guys, you need to select the proper sign. So we decided it's going to be less than 0. Yes. And we're going to hit compute. You're going to get test statistic is negative 0.736 and the p-value is 0.2412. I made a mistake when I entered the number. This number should have been a -2, but I put -1, I think, by mistake. So let's do it again. Stat, t-stats, one sample with data. Variable 3. And what we're doing here, we're testing less than 0. Okay, and then hit compute. And here we go. So t is negative 0.887 and the p-value is 0.2004. P-value, guys, is more than alpha, so we're going to fail to reject the null hypothesis. And if you fail to reject the null hypothesis, you cannot support the claim. So you say there is not enough evidence at the 5% level of significance to support the claim that the rating after the debate are higher than those ratings before the debate. Okay, that's a complete question. Carla is comparing automobile insurance premiums in Arizona with those in California. A random sample of 32 insurance companies in Arizona yielded a sample mean of 735 per year with a known population standard deviation. Guys, once you are given the population standard deviation, you cannot use T anymore. You have to use Z-stats of 185. An independent random sample of 36 insurance company had a mean of 820 with a population standard deviation of 225. Test to see if the data supports the hypothesis that insurance premiums are lower in Arizona than they are in California. These are independent samples, guys, so we don't use the technique that we used in the previous question. So you just need to test that mu1 is less than mu2. That's the claim. And the null is an equality statement, so mu1 equals mu2. So what we're going to do here, not t-stats here, it's going to be, guys, z-stats. Remember that. And why z-stats? Because he gave me population standard deviation. Once he gives you a population standard deviation, guys, you cannot use t. You must use z. Okay? So let's go. So you go to z-stats, to sample with summary, and you enter the information for each sample. So here's the data for sample 1. The data for sample 2 uses z-stats, and we want to check that mu1 is less than mu2. Just put the less sign here. That's it, guys. And if you want to plot the p-value, you can select it here, compute. That's what we have. Test statistic is negative 1.71, and the p-value is 0.0438. And if you want to see a visual, guys, of the p-value, let me show it to you. Here it is. It's an area to the left of the test statistic. Okay. So the test statistic is negative 1.71. P-value is less than alpha. We reject the null hypothesis. And what's our conclusion? There is enough evidence at the 5% level of significance to support the claim that the insurance premiums are lower in Arizona than they are in California. Okay, that concludes this question. So we have this question right here. The Internal Revenue Service gets frequent complaints that their tax auditors are rude and they harass citizens whose returns are being audited. To try to improve public relations, the government conducted a one-day sensitivity training seminar for the auditor. A random sample of 10 auditors who participated in the seminar was selected. The data below records a number of complaints those auditors received before and after the training. Test the claim that the average number of complaints during the period after the sensitivity training decreased. After the period has decreased as a result of the training session. So we want to see if as a result of being trained, you get less complaints. So let's see. What about auditor number 1? It went from 5 to 3. So yes, it did decrease. So that's a yes here. This guy went from 7 to 8. So that's not good. 2 to 3, not good. 3 to 2, good. So you put a yes under it. 8 to 5, yes. 9 to 7, yes. 6 to 6, no change. 4 to 5, no. That's the complaints went higher. And then 10 to 9, yes. Now, guys, I'd like you to look above the yes. What do you see, positive or negative? You see it plus, plus, plus. So this is what we need to test. We need to test that mu of t is greater than 0, mean of the difference is greater than 0. So let me show you how to do that. I put the data already in there. You go to stat. T-stats. For dependent sample T-stats, one sample with data. Select it. All right. And now what we're testing the difference to be greater than 0 right here. We don't touch the 0. And if you want to see the p-value plot, you can do that as well. So compute. Oh, I made a mistake. It's not z-stats, t-stats, but I selected t-stats by mistake. So let me do it one more time. Stat, t-stats. one sample with summary. Not with summary, with data. So stat, t-stats, one sample with data. Select the data, that's right here. And perform greater than 0 for the alternative, and it's always equal sign on the null. And we can hit compute. And here we go. Test statistics 1.048 and p-value 0.1611. 1611 is greater than alpha, guys, so you fail to reject the null hypothesis. And you say there is not enough evidence at the 5% level of significance to support the claim that the sensitivity training session was effective in decreasing the number of complaints. That means the train is no use. They can discontinue this training. Okay, a random sample of 800 people showed that 120 of them had purchased or were planning to purchase a fishing license. An independent random sample of 700 people, 720, showed that 114 of them had purchased or were planned to purchase hunting license. Does the data indicate that the proportion of people who hunt is different from proportion of people who fish? Different is obvious, guys. You need to use not equal, and the null will be P1 equals P2. So we're going to use proportion stats to sample with summary, input N1 and X1, and see what happens. So let me show you how to do that. So you go to stat, proportion stat, to sample with summary, a number of successes 120, number of observations 800, number of successes I think it's 114, and that was 720 if I'm not mistaken. So the test statistic Z is negative 0.45, p-value is 0.6531, which is bigger than alpha. You fail to reject the null hypothesis. And guys, when you fail to reject the null hypothesis, you cannot support the claim. So you say there is not enough evidence at the 5% level of significance to support the claim that the proportion of people who hunt is different from proportion or who fish. An overnight package delivery service has a promotional discount rate in effect this week. For several reasons, the mean weight of packages delivered by this company has been 10.7 ounces. A random sample of 12 packages mailed this week has a sample mean weight of 11.81 with a standard deviation of 2.24 ounces. Test the claim that the mean weight of all packages mailed this week is greater than 10.7. So we go to StatCrunch, stat, t-stats. One sample with summary. Sample mean is 11.21, I believe. Let me check. Twelve 2.24. So for this one, again, we go to stat, t-stats, one sample with summary. Sample mean is 11.81. Sample standard deviation 2.24. Sample size is 12. And we're testing against 10.7. And we need more than, of course. We hit compute. We get tested statistic is 1.717 and p-value is 0.057. Okay. And let's see now, let's go back to the exercise. So the p-value is 0.057. We're testing at 1%, so this is bigger than 1%. Fail to reject HO. And what is the conclusion? There is not enough evidence at the 1% level of significance to support the claim that mean weight of all packages, mean weight of all packages mailed this week is more than 10.7 ounces.